All right, today I'm going to be introducing the way that heat can be transferred from one object to another or from one part of something within itself to another spot. So there technically are other ways for heat to be transferred, specifically through like phase changes. So like when water goes from liquid to gas or gas to liquid, liquid to solid, there is either like energy released or energy gained. But in this case, we're just going to be talking about the way that energy transfers or how heat transfers through three processes: conduction, convection, and radiation. So to start, the simplest version of this is conduction. Conduction is when a solid, so any solid, transfers heat within itself or from one solid to another solid. So in this case, it's going to be like if I hold the end of this sink, my hand and arm, we're heating up this metal here. So by heating up this metal, this part of the metal is now getting hot, and eventually that heat is going to spread through the rest of this metal. That is called conduction, and that's when things literally transfer heat within themselves. So when solids transfer heat within themselves, the sink isn't moving anywhere, right? The sink isn't flowing, right, or releasing any visible light. There is some infrared light, but don't worry about that yet. The point is that when I hold onto the end of the sink, I can feel it heating up, and then this is going to be heating up through here. The heat spreads through itself, through a solid. Same thing happens with the table. I put my hand on the table. Technically, there'd be like a little bit of heat transfer coming off of myself, going into the table, and that's called conduction. Heat traveling through a solid. The next form of heat transfer is going to be convection, okay? So convection is when a fluid, which is a liquid or a gas, anything that you can move through freely, right? A table is not fluid because I can't move through it freely, but a liquid is something you can move through freely, right? I can just go through the water, right? And it is when heat rises and cold things sink. So heat rises because air expands, or liquids expand a little bit as they heat up, making them less dense. And remember, things that are low density rise and things that are high density sink. So like rocks sink in water and wood floats in water. That's because of their densities. So if we have water, which I have water here, ice water, you can't see that it's ice water, but it's cold. I put a bunch of ice cubes in there recently. And let me just move this. Okay. So you should be able to see this. And I'm heating up this pink water here. Not to the point where I'm going to burn my skin, but I'm going to make it pretty hot, right? So just a warning, I'm very safe about this. In this case, I'm not making this boiling hot. I'm just making this warm, and I'm heating it up. And while it heats up, we can actually see the convection from air. So if I hold this over this, you'll see it starts to move around. So let me see if I can get that flow going. See how it's dancing around? That's because the air around here is rising, and the heat is rising, and we're going to be seeing that warm air moving up. So now I'm going to take this hot pink water, I'm going to carefully place it into the cold water, and we should see, yeah, there we go. Okay, so I don't know how well you can see that. I'll turn the light on, and we can see the rising of the heat. So the top layer is becoming that pink, and the cold water is actually going in and pushing out that hot water. And we can see that convection. So it's when heat rises up. So let me see if I can show you another perspective. So you could see the heat rising up and out of there, floating to the top. And this is convection. So not only do liquids convect, liquids are a little easier to see the convection, but so do gases, all right? So I'm making this real hot right here. This is really hot. And if I hold this over this, you'll see that the air is actually going to force it to spin. The rising air over this heat tray is causing it to rotate. So the air around here is cool, and it gets pulled in, and as it gets over this, I can feel the heat coming off of it, and it's rising upwards. rising upwards. So far we've learned about conduction, which is when a solid heats up, right? So when I heat up a solid, I'm passing energy or heat through the solid. We've also learned about convection, which is where gases or liquids, when they are hot, they expand and rise. When they are hot, they expand and rise to the top, and the cold things sink down. And that creates a convection current, which looks like this. So over this plate right now, we have cold air moving in. It heats up, it rises, expands, and cools. Eventually it sinks back down into the room, and then it works its way back over here. It rises, expands, and cools. The final one is probably the most interesting. It has to do with radiation. So radiation is a scary term to hear. We usually think like, oh, radiation, I'm going to get sick from that. Really, all that radiation is talking about is light. Now, we can only see a small part of light. We call it visible light or white light. And then there's another part of the spectrum where there's a longer wavelength, like infrared, microwaves, and radio waves. And then there's a shorter spectrum on the opposite side of purple, which is going to be our ultraviolet, X-rays, and gamma rays, increasing in energy. But just to prove that light carries energy, if we were in outer space and I turned on this light is going to hit into this, and you can see it actually causing that propeller on the inside to spin. So I'll show you again. We've got dark sides on the flag, and on the opposite side are light or white sides of the flag. So what happens is, as you may know, when you wear a dark t-shirt outside, a black t-shirt outside in the summer, it's hot. Black absorbs light better. It doesn't attract light, but black absorbs light a little better. So when we turn this on, the dark sides of those flags heat up, and the white side reflects, and that causes it to spin. So it's the light heating up those different surfaces that are causing this to spin. So light has energy in it. And like I said, this would work in outer space, okay? Meaning that there doesn't have to be a solid, a liquid, or a gas for light to travel through. If that was the case, we wouldn't see the sunlight. Since we do see the sunlight, clearly radiation is able to travel through solid, liquids, and gases, and also nothingness, so the emptiness of space. So we learned three things. Conduction is when heat travels through a solid. Convection is when heat rises in a gas or rises in a liquid, and cold stuff sinks in the liquid or the gas. And then the final thing is radiation, which in this case is going to be light. All right? All ways that heat can be transferred.